Hi, in this tutorial I will show you how you can use Raspberry Pi in combination with Python. And before we start, I will introduce some of my Python resources. So this tutorial is part of Python for software development. You can download the textbook and other resources like videos, examples, etc. from my webpage. In addition to the Python for software development, I have made other Python textbooks and lots of other resources. The other Python textbooks are Python programming, Python for science and engineering, and Python for control engineering. These textbooks and additional resources can be found on my webpage. So let's start with this tutorial. First, I will give a short overview of Raspberry Pi. Then I will show how you can use Python on the Raspberry Pi device. Then I will use this Tony Python editor, which is part of the Raspberry Pi operating system. Then I will go through some basic Python programming examples and introduce some important Python libraries or packages that is important to use in combination with Raspberry Pi. Then I will use the general purpose input-output pins that is available on the Raspberry Pi and see how you can use Python to program these pins. Let's start with the Raspberry Pi. So Raspberry Pi is a tiny low-cost single board computer. It's about 9 times 6 centimeter large. It costs about $35 for the 2 gigabyte edition. Then you have 4 gigabyte and 8 gigabyte editions. The Raspberry Pi is running on a Linux operating system, and the recommended operating system is called Raspberry Pi operating system, which is a Linux-based operating system. You can find out more about the Raspberry Pi hardware on the home page for the Raspberry Pi, raspberrypi.org. So with the Raspberry Pi you have everything on a small single board. You have the microprocessor, you have RAM, where you can select 2, 4 and 8 gigabyte of RAM. You have the so-called general purpose input pins, which we'll use later in this tutorial. You have an Ethernet connector. You have 4 USB-A connectors. You can connect 2 monitors using micro HDMI connectors, and you can connect power supply using this USB-C connector. In addition, you can connect a camera using the camera connector. In order to install the necessary operating system on the Raspberry Pi, you need to install the operating system on an SD card, which you do on your desktop computer. And when you have installed the necessary operating system on the SD card, then you just insert the SD card into your Raspberry Pi device, and then you can plug in the power supply, and then you are up and running. So in order to get started with the Raspberry Pi, you need the following hardware components. You need a Raspberry Pi device. You need a micro SD card. And you are setting up this micro SD card on your desktop computer, so you typically need an adapter as well. You need a power supply. You need a micro HDMI to HDMI cable in order to connect an external monitor. Of course, you need a monitor, you need a mouse and a keyboard. So as mentioned, you need to install the Raspberry Pi operating system on your micro SD card in order to make your Raspberry Pi device up and running. So this Raspberry Pi operating system, previously known as the Raspberrian operating system, it runs on Linux. It's a Linux operating system. and you need to have this micro SD card. Then you just go into this web page, follow the step-by-step instructions in order to install the Raspberry Pi operating system on the micro SD card, and then you just insert the SD card into your Raspberry Pi device, connect it to a monitor, keyboard and a mouse, plug in the power supply, and then you are ready to go. So when you have plugged in the Raspberry Pi device in combination with your monitor, mouse and keyboard, and connected the power supply, you should get the following welcome screen. So basically this is the Raspberry Pi operating system, where you have the start menu, just clicking on the Raspberry Pi icon in order to use the application that is part of the operating system. You can also remotely get access to the Raspberry Pi on your on your desktop computer. So you need to install a software called XRDP, which is a open source implementation of the Microsoft Remote Desktop Protocol. So you install it just using this command in the terminal window on the Raspberry Pi operating system. Then you can open your remote desktop connection on your desktop Windows computer, or if you have a Mac computer, this remote desktop connection is also available for Mac OS. So basically, in order to use Python on the Raspberry Pi device, you need to have a Python editor, and as part of the Raspberry Pi operating system, we have this default Python editor called Tony. So it's a very simple and basic Python editor, but it's quite easy to use, and it has all the features you need in order to create different Python applications for your Raspberry Pi device. So let's start it with Raspberry Pi and Python programming. So here you see the Raspberry Pi operating system. So here is the start menu, this Raspberry Pi icon. So just click on it, and then under programming you will find this Tony Python editor. Here you will find an internet browser. Under accessories you will find different applications like a file manager, calculator. You will also find a terminal. If you want to log out of the computer, you just click log out in order to either log out or shut down the Raspberry Pi operating system. So let's start with the Tony Python editor. So you can just click here in order to open it. We can also create a desktop icon. So we have it here on the desktop. So you just double click on it in order to open the Tony Python editor. And basically this is the Tony Python editor. Here you can enter or create a Python script, or here in the shell you can type one Python command at a time. So let's start with just a basic example. You can start using the print command. So print hello or something like this, and click enter, and then the text has been printed to this shell. You can also here in the script do the same. So I can just copy this one into this Python script like this, and click here to save it, and then I can click this run current script button in order to run my Python application. And as you see, you get the same result in this case. You can change it to hello world or something, click the run button. You don't need to save it because When you click the run button, it will be automatically saved, so just click the run button and the script will be saved and then executed, and the result will be present here in the shell window. So that's basic Python. Let's start creating some variables. We can create a variable called x equal to 3 or something, and then type y equal to 2 times x. So we just type 2 times x like this, and then here instead of hello world we can print y like this. So now we have created a variable x equal to 3 and then y equals to 2 times x, and then we just print the result here. So let's just run this example, and as you see, the result y 2 times 3 will be equal to 6, and it will be printed here in the shell window. So that's variables. Let's create some basic mathematical operations. So assume we want to calculate the sign of a specific value. Then you can import a library, in this case the math library. So import math, import everything. Then you can type x equal to pi, which is a built-in constant. Then you can set so x equals to pi, and then we can set y equals to sine of x like this, and then we can print y like this. So let's see what's happening when you click the run button. And as you see, we have now used the math library, which is part of Python, and in that library you have this sine function which we can use, and we have this pi operator, and then we can calculate sine of x, in this case where x equals to pi, and then you can print y into the shell window like this. We can change it to pi multiply by 2 or something. Let's run it, and then you will see you get the correct result in this case. So this is math. Let's change it to the cosinus function instead. You can use the cosinus function, and then the program will calculate the cosinus of x of pi in this case. Let's use some if-else sentences. So here we have created a basic if-else in Python. So in this case we just set a equals to 5, b equals to 5, and if a is bigger than b, then print a is bigger than b, else print b is greater than a or b are equal. So let's just run this one. So now, since b is greater than b, this line of code will be printed to the shell window. Let's change it to so a is 55 and b is 8. Now should a be larger than b, so then this should be printed to the screen. So let's just run it, and as you see, now this was printed to the screen. So this is a basic if-else sentence in Python. Here we see a new example where we have created an array of data. So I have created a variable called data where I have some numeric values. put into an array. Then we can use the statistics library, which is part of standard Python, in order to find the mean of these values, define the standard deviation, the minimum value, the maximum value, etc. Let's just run this example. So we just run this example. Then we can just type m here, and then you see the value for m. Or we can of course use the ordinary print command. You can type SD in order to find the values for the standard deviation value. The data mean is 1.6. Data max is 9.4. So basically this is how we create an array in Python using some of the functions in the statistics module, and then using some of the functions which is part of that module or library. We can also use arrays in combination with the for loop. So here I have created an array called cars, which contains 3 elements: Ford, Toyota and Tesla. And then I create a for loop, and then inside the for loop I print the specific car in each iteration. So let's just run this example. So in the first iteration, car will be equal to Ford. In the next iteration, car will be equal to Toyota. And in the final iteration, car will be equal to Tesla. So this is how we can use a for loop in combination with an array like this. Here you see another example how we can use a for loop. So we can set n equals to 10 like this, and then you can type for x in range. Range is a built-in function, and then you can just type n like this. So here you need a colon, and then we can type print x like this. So now we have created a for loop that has 10 iterations, and in each iteration it should print the value of x. So let's just run it. Yeah, of course. So typing print like this. Let's just run it, and as you see, it just print out x in each iteration. So x is first 0, then 1, 2, 3, 4, 5, 6, 7, 8, and 9, like this. If you set print to, or sorry, n to 209 or something, and let's just run it, and then we will print x from 0 to 108 in this case. We can also specify start value, start for, end is 10 or something, and then you can set for x in range, start, comma, stop, like this, and let's just run it. Stop, oh yeah, we change it to stop, like this, and run it, and then we will print the value from 4 to 9. If you need to include 10, we just need to change it to 11, and then we will print from 4 to 10 like this. So this is how to use a for loop in Python on your Raspberry Pi device. So basically you can create any kind of Python program on your Raspberry Pi device that you can also create on your desktop computer. So if you want to learn more about the basic Python programming in general, either you are using your desktop computer or a Raspberry Pi hardware device, take a look at some of my other Python resources. I have made a textbook called Python Programming, which goes through the basics with the Python program in general. So all the examples inside this textbook apply to Python in general, and it can be applied to if you are using Python on your desktop computer or on your Raspberry Pi device. So the textbook and additional resources with lots of videos are available from my webpage. The videos are also available from YouTube. So you find these Python resources at my webpage. Another good Python programming tutorial in combination with Raspberry Pi can be found here on SparkFun. But let's start creating some or using some Python libraries or Python packages on the Raspberry Pi device. So rather than having all its functionality built into the core of Python, Python was designed to be very extendable. So there exist probably thousands of different Python packages or libraries that you can include in your Python application. Some of the most important packages or libraries are the NumPy library and the Matplot library. If you are using the Raspberry Pi and this Tony Python editor, it's very easy to install these packages. Let's see how we can install different Python packages or Python libraries on your Raspberry Pi device. So in order to install additional Python packages or Python libraries on Raspberry Pi, inside your Tony editor, you can just click Tools and Manage Packages. Then you can just search for the package you want to install. So assume you want to install this NumPy package. Just type the name for the package and click Search. And then we will find the packages or libraries that is according to our search. So then we found this NumPy library here. We can just click on it. And then you see that NumPy is already installed on the Raspberry Pi device. So by default, this NumPy is already installed and ready to use. So let's see how we can use this NumPy library. So you just click Close here, and then you start to import this package or library. So import NumPy as np. This is just an alias. Then you can type x equals to 3, then y equals to np, and name of the function. In this case, I want to use the sine function. So then I just type sine of x like this. Then I want to print y like this. So now I have imported the NumPy library. I used one of the functions which is part of the NumPy library, and then I just print the result to the screen. Let's just run this example. As you see, this Python program calculates sine of 3 and just print it to the screen. So this is how we use an external Python package or library like this NumPy library. Next, I want to use the Matplot library for plotting. So then I just go to Tools, Manage Packages, search for matplotlib, which is the name of the package. Click Search, and then I find it here in the search list. Just click on it, and I have already installed this package. But so by default, this matplotlib is not installed on the Raspberry Pi operating system. So you just click here so if I haven't installed it already, there would be this install button that you could click on here. Or if there is a newer version, you can click upgrade, or if you for some reason want to uninstall it, you can click on the uninstall button. So it's very easy to install these packages on Raspberry Pi operating system. So let's see how we can use this matplotlib. So in this basic example, I just use first the NumPy library, which I import, and then I use the matplotlib, which I import. So then I start by creating an array of x values from 0 to 2 pi, and then here I use the pi constant of the NumPy library, and then I use the arrange function, which is also part of the NumPy library, and then I calculate the sign of each of these values in this array, and then I plot x versus y using the matplot library. So let's just run this example. And in this case, this figure and this plot is popping up. So this is created by using this matplot library. So basically, I'm plotting the sine curve from 0 to 2 pi in this case. So basically, it's very easy to use Python on your Raspberry Pi device. You can use all the Python features that you are used to from your desktop computer. You can also install and import and use external libraries like the NumPy, matplotlib, etc. But in addition, you can use Python and Raspberry Pi for more advanced features that you are not able to do on your computer. And this topic I will cover now, and this topic is called general purpose input-output. So on the Raspberry Pi device, we have a connector called general purpose input-output, which consists of 40 pins that are digital pins that are either true or false. When a specific pin is true, it is plus 3,3 voltage. If it's false, it's 0 voltage. So these pins can be used to turn on or off LEDs, control a motor. We can read value from a push button, etc. And these digital pins can be either input or output. So we can read, if you set it to an input, we can read value from, let's say, a push button. If you set it to an output, we can turn on LEDs, etc. And in addition to these digital pins, we also have more advanced features. And some of these features are pulse width modulation. We have also some digital buses or interfaces called SPI and I2C. Well, let's start with the basic. So here you see the Raspberry Pi device with the USB ports, the internet port, the power supply port. Here we have the ports for the monitor. Here we have the port for connecting a camera, and here we have the general purpose input-output connector. So it consists of, as you see in this larger picture, it consists of 1, 2, 3, 4, 40 pins, where all these pins can be used to either control LEDs, motors. We can read values from sensors, etc. So these are quite a powerful feature that you can only use on your Raspberry Pi device, because an ordinary computer doesn't have these general purpose input-output pins. So here you see a larger picture of all these general purpose input-output pins. So we have pins for 5 voltage power, we have pins for 3.3 voltage power, we have separate pins for ground, and we have these general purpose EU pins, which can be either digital in or digital out. So basically we can connect lots of external components like LEDs, motors, push buttons, whatever, using these pins on the Raspberry Pi device. So let's see how we can use these control and read these pins from your Python programming language. So we can use Python to program all kind of programs on the Raspberry Pi. But these ordinary Python programs can also be programmed using your desktop computer. So the unique thing about Raspberry Pi in combination with Python is to use this general purpose input-output connector. So with these general purpose input-output pins, you can connect to LEDs, sensors, you can control motors, etc. So this is this combination, the Python in combination with the Raspberry Pi and these general purpose input pins that makes this unique. So in order to use these general purpose input output pins in Pythons, we typically need to use an external library. So the most used library is called General Purpose Input Output Zero. So this is a external library that you can use in order to control or read values from these pins on your Raspberry Pi device. Another library is called RPI.GeneralPurposeInputOutput. So this library is a more low-level Python library than this previous one, this GPIO Zero. So actually this library is, this library is actually using this library on the back end. So we will see how we can use these libraries to control and read values from these general purpose input-output pins on the Raspberry Pi device. So in order to follow these tutorials I will show you now, you will need a Raspberry Pi, you will need a breadboard, you will need some LEDs. You can, if you have some push buttons, that's also handy to have. You need some resistors and you need some wires. So let's start with the breadboard. So a breadboard is used to wire the electronic components together. So you put your LEDs, your push buttons, your resistors, and wire the circuit here on the breadboard, and then you connect the components to the general purpose input-output pins on the Raspberry Pi. And in most circuits you need to use some resistors. Typically we need some, the most used resistors in the tutorial here is this 270 ohm resistor, which we will use in order to limit the current that is flowing in the circuit when using a LED. Basically, to know about Ohm's law is also handy. So basically, U are equals to R multiplied with I, which is the current. And the resistors comes in different flavors and values. So you can look up on internet in order to find the value for a specific resistor, or you can use a multimeter. But let's start see how we can control a LED from Python. So we will connect a LED on one of the general purpose input output pins on the Raspberry Pi, and then we will use and create a Python program in order to control this LED. So we will need the following equipment: a Raspberry Pi, a breadboard, a LED, and a 270 ohm resistor, and some wires. So here you see how you wire up the LED on the breadboard and connect the wires to your general purpose input-output connector on the Raspberry Pi device. So basically a LED consists of two pins, one is plus and the other one is minus, and if you add current to this circuit, the LED will start to light. So here is an example how you should wire the LED on your breadboard. So if you connect like this, you will short circuit the LED, because all these holes on the breadboard are connected. So this is the proper way to connect a LED on your breadboard. So here you see a more detailed wiring. So we connect a LED on the breadboard, and we use a 270 ohm resistor, and then we use one of the general purpose input-output pins. In this case, I've used this general purpose input-output pin number 16, which is actually pin 36 of this connector. So I connect this one to the positive part of the LED, and then the circuit goes through this resistor, and it goes back to one of the ground pin of this connector. So basically this is how you connect a LED to this Raspberry Pi general purpose input-output connector. So let's start creating the Python application for this example. So here you see the Python program for this example. We need to use this general purpose input-output zero library. In addition, I have use a function in the time library as well. Then we need to specify which pin we are using. So we are using general purpose input-output pin number 16. Then we set the pin to be number 16, and then we just define or connect the LED to that specific pin using this LED function of this general purpose input-output zero library. Then we can use a while loop or something. Then we can use the LED.on in order to turn the LED on. Then how using this sleep function of this time library. So when the LED is turned on, the program will sleep for 1 second, and then it will turn the LED off, sleep for 1 second, and then it will go into an eternal loop until I stop the program. So let's implement this application on our Raspberry Pi device. So let's start creating the Python program for controlling this LED. Let's start by installing this package. So then you just search for this package or library, general purpose GPIO Zero. Click search, and then just click on this library in the search result. And as you see, I have already installed this library. So then I can start using this library. If you hadn't installed it, then it would be this install button you can click on here in order to install this library. But basically we don't need to install this library, because this library is part of the Raspberry Pi operating system. So you can just close here, and then we are ready to use this library. So we start importing this library from general purpose GPIO Zero, and we want to use this LED feature of this library, and we want to import this time library as well. From time import, and you want to use this sleep function. And we have connected to LED on pin 16. And then we just specify a variable called LED equals to LED and the pin number, like this. So now we have defined that we have connected a pin to, connected a LED to pin number 16 on the general purpose input-output connector on the Raspberry Pi. Now we can start using this while loop. So while true means that the program will run forever, like this. And then we can use this LED.on function, like this. And then we use this sleep 1, then the program will sleep for 1 second, like this. And then we want to turn off the LED off, like this, and we want the program to sleep for 1 more second. And then it will go into this loop until we click the stop button in our Tony Python editor. So let's just run this example. So now the program will run forever, and it will turn the LED on and off in an eternal loop until we click this stop button. So basically this is how you can control and use these general purpose input-output connectors on your Raspberry Pi device. You can also, instead of a while loop, we can use a for loop. So assume we want to have a for loop that runs in in 10 iterations, like this. And you can have a for x in range of n, like this. And now we can click the run button once more. Yeah, of course, install a uppercase N. Let's run it. And now it will run for 10 iterations, turning the LED on and off it in each iteration. And in between, it will wait or sleep for 1 second. And now you see the program is finished execution. So basically, this is how you can control and use the general purpose input-output pins on this Raspberry Pi device. So basically, here you see my Raspberry Pi. I have connected a LED to this input-output connector, and as you see, the LED turns on and off like this until the program stops. So here you see the circuit. I have wired it using this pin. This blue cable is this general purpose input output pin, while the gray one is ground. I have connected it to this basic circuit using a LED and this 270 ohm resistor, like this. So that's all. So if you want to learn more about Python and Raspberry Pi, take a closer look at some of my other Python resources. You find them on my webpage. So that's all. So good luck with Python and Raspberry Pi. Thank you.